Welcome. So today we're looking at this question here. It says the spring is attached to the ceiling and pulled 16 centimeters down from equilibrium and released. The amplitude decreases by 6% each second. The spring oscillates 20 times each second. Find an equation for the distance d. The end of the spring is below equilibrium in terms of seconds t. So d of t is equal to something, and we want to figure what that is. So where we're going to start is actually by looking at this part here, that the spring is pulled down 16 centimeters and amplitude is decreasing by 6% each second. So in other words, the amplitude is a function of time. And we know that the amplitude is going to be an exponential function because it's decreasing percentage-wise, 6% each second. So the initial value, little a, is going to be 16, and b, the base, since we're decreasing by 6% each second, be 1 minus 0.06 to the t. So b is 1 minus 0.06. So you get 16.94 to the t for the amplitude. Okay. Now, we need to find a function that could model this situation well. We see that it's pulled down from the ceiling. So we're starting at the low point, okay, which would tell us that we're looking for a cosine function. Because we're starting at a low point. If you start at a midpoint, midline, at the midline, then you use a sine function. If you're starting at the maximum value, you'd again use a cosine function. So far, we're looking for a function d of t, which is equal to a of t cosine of bt minus c plus d, where d is a midline, c over b will be a phase shift, and b is the period. Now here, we're also given another piece of information. The spring oscillates 20 times each second. So in other words, that will give us the frequency f. The frequency is 20 times per second. Now we know that the frequency is equal to 1 over the period p. So we know that that's equal to 20. So that would imply that 20p is 1, or that the period p is 1 over 20. So we're given that now we've found the period. Now we look at b, this coefficient. We know that the period p is 2 pi over b. So now we can solve for b. So we got 1 over 20 is equal to 2 pi over b. We have a proportion. We can cross multiply. We get b is equal to 40 pi, right? And that would be the coefficient b. So far, what do we have? We have a of t. We have the coefficient b. C is a phase, C over b would be a phase shift. So there's no phase shift here, so actually C is 0. And the midline we're taking to be just y equals 0, so actually D is 0 as well. let's put it all together. So here you have it, y is equal to a of t cosine of bt. So d of t, that's what we're looking for, is going to be a of t, which we found to be 16.94 to the t cosine b of t. Now since d of t is a distance, okay, we know that a of t will be a positive value. Okay, so in other words, because this is a distance function, the minimum value it could be is 0. So this is strictly non-negative on the outset at least, because if we plug in t at 0 here, we're just going to get cos of 0 is 1, and we're going to get 16 centimeters. So that's exactly what we want, because we pulled the spring down 16 centimeters initially, right? In other words, we satisfied an initial condition that d of 0 is equal to 16 centimeters, right? So this really completes our problem right here. So have a good one. Take care.